You wouldn't know from looking at toluene diisocyanate that from it, some of our most useful products are produced. TDI, as it is commonly called, is used in the production of furniture cushions, automobile seats, mattresses, and other flexible polyurethane foam products. Each year, millions of gallons of TDI are loaded at manufacturing plants and shipped to end users in a variety of containers. Among the most common are drums, intermediate bulk containers, tank containers referred to as isotainers, cargo tank trailers, rail tank cars, and various smaller containers. TDI production facility employees take pride in their safety record while preparing products for transportation, and want this same pride in safety to take place at all receiving points as well. Shipments to customers are made by a variety of transportation modes: highway, rail, water, and air. All transportation personnel, as well as those who use TDI, need to be aware of the potential hazard to both themselves and the environment in the event of an accident during the distribution process. It's important to remember that although TDI may have potential hazards, they can be minimized when handled safely. In order to provide you with all the information necessary to safely handle TDI, this presentation has been divided into 6 equally important segments: hazard communication, drum and intermediate bulk container handling, tank container transfers, cargo tank trailer transfers, rail tank car transfers, and how to respond in an emergency. Toluene diisocyanate, commonly called TDI, and its derivatives will react with water, including moisture in the air, polyol, or any alkaline compound, such as ammonia or detergents. Because of this reactivity, these materials may present potential physical and health hazards during handling. In this hazard communication section, we will discuss the physical characteristics of TDI, the routes of entry, potential health effects of overexposure, first aid procedures, and the personal protective equipment required when handling TDI. Physical and chemical testing provide both manufacturers and customers with information necessary to protect employees, as well as information pertaining to the physical properties of the material. Physical data testing has shown that at temperatures above 57 degrees Fahrenheit, TDI will remain in liquid form. At temperatures below 57 degrees Fahrenheit, TDI will begin to solidify. At about 77 degrees Fahrenheit, TDI has a viscosity similar to water. TDI has a flash point above 375 degrees Fahrenheit. Thus, it is not ignited readily. However, it will burn if exposed to an ignition source at or above the flash point temperature, and fires are possible if proper care is not taken. Additional information can be obtained from the Material Safety Data Sheet, MSDS, or the technical data sheet accompanying the product. Testing has also shown that TDI is reactive with certain types of materials, including water. When these are mixed together, heat and carbon dioxide are generated. Over time, this can create excessive pressure in closed containers. It's extremely important that TDI should not come in contact with moisture or water during transfer operations. Other reactive agents include, but are not limited to, ammonia, polyols, alcohols, amines, caustic soda, and caustic potash. TDI is a clear, water-white to pale yellow liquid. It has a sharp, pungent odor that can be very irritating to the respiratory system. The odor threshold for TDI is above the established exposure limits. Therefore, odor should never be used to indicate the presence of TDI. Let's take a look at some of the potential health effects associated with TDI overexposure. For a chemical to cause health effects, it must make contact with or enter the body. There are three major routes of entry through which this can occur: inhalation or breathing, skin or eye contact, and ingestion or swallowing. You should be aware of these routes of exposure when handling TDI. If overexposure by any route occurs, seek immediate medical attention. The greatest health hazard of TDI is the potential for adverse effects on the respiratory system. At room temperature, TDI can form vapor concentrations above the permissible exposure limit. TDI can cause irritation of the eyes, nose, throat, and lungs. Difficulty breathing, tightness in the chest, and coughing are also symptoms of overexposure. In most cases, these symptoms will disappear within a few hours after the exposure takes place. Overexposure to airborne TDI may cause respiratory allergy or sensitization. Skin contact may also be associated with respiratory allergy. Once sensitized or allergic to TDI, a person may react to extremely low airborne concentrations of TDI. Anyone who shows signs of irritation or asthma-like symptoms should be moved to fresh air and given immediate medical attention. The onset of these symptoms may occur immediately or be delayed. Therefore, medical personnel should observe overexposed individuals for several hours after exposure. Liquid TDI can be irritating to the skin or eyes. Skin contact may result in redness and may also cause skin sensitization and allergic reaction. Symptoms such as redness, itching, and rash may occur when a sensitized person contacts TDI. Once the person has become sensitized, that individual should no longer work with TDI. For skin exposure, wash with soap and water. Remove any contaminated clothing. For exposures requiring the use of emergency showers, remove contaminated clothing and other sources of vapor before removing respiratory protection. Eye contact may result in redness and tissue injury may occur. Therefore, it is important an eye wash station and safety shower be located in the immediate area when TDI is being handled. For eye exposure, flush the eyes with running water for at least 15 minutes and then seek medical attention. Although unlikely, accidental ingestion or swallowing of any chemical could occur. TDI has a low potential of toxicity by ingestion. For ingestion of TDI, do not induce vomiting. Seek medical attention immediately. Eliminating exposure at the source will prevent these potential health effects. As with all chemical shipments, hazard communication information is attached to all containers, either by a warning label or tag. If additional handling information for TDI is required, please refer to the manufacturer's material safety data sheet. Everyone involved in the handling of TDI must be equipped with the appropriate personal protective equipment. This includes appropriate impervious clothing such as chemical protective suits, chemical-resistant gloves and boots, as well as an approved full-face air-supplied respirator. To prevent overexposure to airborne vapors, the Occupational Safety and Health Administration, OSHA, and the American Conference of Governmental Industrial Hygienists, ACGIH, have established exposure limits for TDI. Airborne concentrations must be kept below these limits. The odor threshold, or point at which you can detect TDI with your sense of smell, is above the permissible exposure limit. Therefore, odor should never be used to indicate the presence of TDI. Since TDI has poor warning properties, the workplace should be periodically monitored for airborne TDI. If you can smell TDI, you may be exposed above the permissible exposure limit. Since harmful airborne concentrations may occur unexpectedly, a positive pressure self-contained breathing apparatus or a positive pressure airline respirator should be readily available in areas where TDI is handled. These should be worn to prevent overexposure to airborne vapors should a release occur. Approved respiratory protection must comply with OSHA requirements. In this hazard communication section, we have covered the physical characteristics of toluene diisocyanate, the routes of entry, potential health effects of overexposure, first aid, and the appropriate personal protective equipment required for safe transfer operations. If you have any further questions or are unsure of the actions required of you, ask your supervisor or team leader, or contact the product manufacturer. For more information on the topics covered in this section, consult the following literature developed by the Center for the Polyurethanes Industry: Model Respiratory Protection Program, TDI User Guidelines for Protective Clothing Selection, Industrial Hygiene Air Monitoring for MDI and TDI,